Okay, this is number 7 on 7.1. Hopefully you had a chance to take a look at this, try it on your own. I kind of filled in a little bit so we could see what was going on. This was the velocity equation was equal to e to the sine t cosine of t on this interval. So like we've done on the other problems, we want to find out where it stops. So that's when my velocity is 0. So we set this equal to 0. Now the reality is that this is always going to be positive. This will never be equal to 0, so the only time this product will be equal to 0 is when the cosine of t is equal to 0. So all I have to worry about is the cosine being equal to 0. So this is kind of like, I think, number 1. So remember the cosine is positive from 0 to pi over 2, then it's negative from pi over 2 to 3 pi over 2, then it goes back to positive. So it stopped. It's actually 0 at pi over 2 and 3 pi over 2. So that's when I'm stopped. So I'm going right when it's positive from 0 to pi. I'm going right. And then from 3 pi to 2 pi. I'm sorry, 3 pi over 2 to 2 pi. That's when I'm going right. And these are open. This actually should be closed here. Sorry about that. And I'm going left when it's negative from pi over 2 to 3 pi over 2. And it stopped again when t is pi over 2 and 3 pi over 2. So that was the A part. Okay, I wrote that down to save a little bit of time. Now the B part is we want to find the displacement. So remember V of t, which equals ds dt. That's going to be equal to, again, this e to the sine t cosine of t. So we'll separate the variables. So we have ds equals e to the sine t cosine t dt. All right. And then we'll take the integral of both sides. And that's on this interval from 0 to 2 pi. So from 0 to 2 pi, 0 to 2 pi. And then again, this is just going to be on this interval, this will be the displacement. So from 0 to 2 pi, this will actually be my delta S. That's going to be equal to this integral. From 0 to 2 pi of e to the sine t cosine t dt. But if you look at this and if you think of this sine t as u, what's the derivative of the sine t? Well, the derivative of the sine t is the cosine t dt, so that's my du. So it looks like I've got e to the u du. So that makes it nice. That means this integral will be just the antiderivative of this will be just e to the u, which is e to the sine t. And I'm going to evaluate that from 0 to 2 pi. Well, sine of t, when t is 2 pi, the sine of 2 pi is 0, e to the 0 is 1. And when t is 0, the sine of 0 is 0, and e to the 0 is 1, so we have 1 minus 1. So again, we have 0 displacement. So again, my final position is going to be my initial position, S sub 0, plus my displacement, delta S. And my S sub 0, again, was given to be 3, plus my displacement, which is 0, so it's just 3. So my final position, again, is 3. Okay. And then the last part. Okay. We want to find the distance traveled, so the distance traveled, again, will be the absolute value distance traveled. Okay, that's going to be the equal to the absolute value of my integral from 0 to 2 pi of the absolute value of e to the sine t cosine t dt. Now we already know what that's going to be because we looked at we had our graph. So we know we're going to have positive here, and this is negative, so we have to take the negative integral there to make it the absolute value, then we'll go back to positive. So that's going to end up being the integral from 0 to pi over 2, that's where it was positive, of the actual function e to the sine t cosine t dt. And then this will be the negative part, so we have to negate that, so that's going to be the integral from pi over 2 to 3 pi over 2 of our function e to the sine t cosine t dt, and then plus, put it down here, the part that was also positive, so we don't have to negate that, and that's going to be the integral from 3 pi over 2 to 2 pi of e to the sine t cosine t dt. And we know this again was e to the u du, so that's just going to be e to the sine t. That's going to be evaluated from 0 to pi over 2, and then minus e to the sine t, evaluated from pi over 2 to 3 pi over 2, and then plus e to the sine t, evaluated from 3 pi over 2 to 2 pi. So when you put these values in, okay, the sine of pi over 2 is just 1, so that's going to be e to the 1, minus e to the 0, sine of 0 is 0, minus, and again this is going to be sine of 3 pi over 2, that's going to be the sine of 3 pi over 2 will be negative 1, so that's going to be e to the negative 1, minus the sine of pi over 2 is 1, so e, or e to the 1 if you want, plus, and then this is going to be the sine of pi over 2, which is 0, so that's going to be e to the 0, minus e to the sine of 3 pi over 2, and that's going to be negative 1, so it's going to be e to the negative 1. So when we simplify this all out, we have e minus e to the 0 is 1. Now negate both of these, so this is going to be negative 1 over e plus e, and then plus e to the 0 is 1, and minus 1 over e. So we simplify these, it looks like I've got 2e, and the negative 1 and positive 1 cancel, and I've got negative 2 over e. And if you work that out on your calculator, you get approximately 4.7. But this answer would be acceptable if it was a non-calculator problem. So I hope that helps, and I hope you get everything. Good luck.